And I'm going to first is I told you whenever you have a two-stage amplifier, we have to analyze in the reverse side. We have to analyze the second stage and then come back to the first stage. The second stage, you see, the current gain AI2 is given by IC2 by IE2. And you know that it is HFE by 1 plus HFE, beta by 1 plus beta. It is going to be alpha. So the current gain for the common base amplifier is given by alpha. Alpha is beta by 1 plus beta. We have studied this in devices, right? Same thing. Alpha equal to beta by 1 plus beta, same thing. And Ri2, you see, it is HIE by 1 plus HFE. Whenever you have an emitter, Ri2 is the input impedance of this side. So Ri2 equal to HIE by 1 plus HFE. And the voltage gain for the second stage is given by this formula. See, these formulas we have studied in the cascading basics. The AV2 equal to AI2 into RL by Ri2. So if you take the second stage, all parameters will have a suffix of 2. When you take the first stage, all parameters will have a suffix of 1. So AV2 equal to AI2 into RL by Ri2. First stage, you know, in the common emitter amplifier, the current gain is given by HFE, the input impedance is given by HIE, the voltage gain is given by AI1 into RL1 by RI1, RL1 equal to RI2. Since you are going to connect the two amplifiers in cascade, the load of first transistor will be equal to the input impedance of second transistor. So RL1 will be equal to RI2. So when you substitute and find the when you substitute and do the problems, you have to take this formula for finding out the voltage gain for the first stage. So for voltage gain, multiply both. So, you know, in when you cascade amplifiers, you have to multiply the voltage gain. So voltage gain will be AV1 into AV2, AI1 RL1 by RI1 into AI2 into RL by RI2. Input impedance, everything is in parallel. You see the circuit, everything is in parallel. Okay, so I am writing everything in parallel. Ri1 parallel to Rb, Ri1 parallel to Rb is R3 parallel to R4. Overall voltage gain including Vs, so AVs equal to V0 by Vs. So I'm multiplying this V0 by Vi into Vi by Vs. So AV into voltage division technique, Ri by Ri by Rs. Current gain, multiply all the currents, you will get the expression like this. And the output impedance, if you consider, see the output side, if you consider this RL, it will be RL parallel to infinity, it will be RL. If you don't consider this RL, it is going to be the current source, so the value is going to be infinity. So it depends on whether you consider RL or not. So if you consider RL, the output impedance will be equal to RL, because RL parallel to infinity. If you don't consider RL, only the current source will be there, so the input impedance will be equal to infinity. So this cascode amplifier is one special amplifier where you have cascading of common emitter in the first stage followed by common base. Don't get confused. Darlington pair, you have both common collector configuration. In normal cascaded amplifier, you have two common emitters. So we have seen different varieties of cascading of